Hey guys, this is the video for our test right now, chapter 5. So you really only need one formula for this. That's the z-score is equal to x minus x bar over s. X bar is the mean and s is the standard deviation. You're going to be probably given at least 3 of these things to find the fourth one. For example, you're given the z-score, you're given the standard deviation, you're given the mean, and you need to say, hey, what is the number that whatever this x is going to be? What is the x with this z-score in this situation? Every single situation is a different standard deviation and a different average, obviously. So, how to use the calculator. More importantly, what do you need to use the calculator for? So, let's first explain that. The thing he said in class about using this feature right here, where is it? It's going to be second distribution down here. The thing that he said, which is the normal CDF function, is actually finding the area underneath a given part of a little bell curve like this. For example, the area between -5 and 4 on this bell curve specifically. So I wrote mean in the middle where at the 2 is. So notice I'm given all 3 things that I need to know, and let's assume that the standard deviation is 1. Let's just assume that for this question. So you clear that. For the lower, we're at -5, so -5. The upper is going to be 4. The mu, or the mean, is going to be 2. Okay? This little O that kind of looks like that O thing, that is your standard deviation. As I said, just assume it's a 1. Click on paste, press enter again, and it gives you that number. That number is the area underneath this, in this segment. Okay? So 0.977. That is this area, the shaded part. What about that thing he said about the inverse normal, or whatever it was called? Second vars, again, inverse normal. Look at that. What does it do? So basically, you're given the area, 0.977. We said that, 0.977. The mu is the mean, so that's 2. Okay? Oh, wait. That's standard deviation. I skipped one down. 2, okay? Standard deviation is 1. Paste it, enter again, and that gives you your z-score of this right here. Okay? Okay? That's your z-score. This is really important. I actually like using this more than the calculator, because now whenever you're given your z-score or you're given a percentile, you can find your z-score. I find this is a lot easier to use in the calculator. The calculator just overcomplicates this. This is relatively simple. So, say you have a z-score of -2.01. So you're going to go to -2.0 over to 1. 0.0222. That is the percentile it's in. So it's 2% is that z-score for any example. So I have this example right here. I say, what is the number all the way down here, say -30. And say -30 has a z-score of 2.01, that's going to be exactly, what, the 2% that we got before. So you're using this to find yourself the percentile. A lot of questions on the homework and probably a lot of questions on the test are going to ask for what is this percentile, what is the 90th percentile. So what do you do if it asks what is the 90th percentile? That's actually pretty easy. That makes it's a lot easier than the calculator. All you do is you look for 0.900, or as close as you can get to it. In this case, I happen to know it's exactly 0.8997 or something like that. It's really, really close, but it's not in the 9s, and it's right over 0.8997, right there. That's 0.8, 1.28. So that's what it is. 1.28 right there. That's 90th percentile. Okay? Pretty simple. Use this more than you use the calculator. I find it more simple, more straightforward than the calculator. The calculator is asking you for these Greek symbols that no one even uses. Well, this is simply z-scores, percentiles in decimal form, and pretty simple. These things are, well, not as important. You can leave them alone if you really want to. These are the important ones you need to use, top and bottom. This is simply negative, this is simply positive. To understand this better, this is going to be, if you look over here, on that side of the graph, and up here you're looking at that side. See? It's just how the graph is split up. If you want to learn more, Google it. I'm not exactly sure how that works.